This is Precalculus Concept 8C, horizontal shifts and graphs that are going to have horizontal shifts. We've got three boxes here. Box 1 is going to be a concept. If you have a function and c is some positive real number, we're going to look at the graph of f of x plus c as it relates to the graph of f of x. So when you graph f of x plus c, first thing to notice is the plus c is in a different place this time. Rather than being the function with the plus c off to the right, it's actually the function evaluated at x plus c, which is a different thing. And what ends up happening is the graph is moved to the left by c units. So what you want to think about when you have this scenario is a graph of f and every single point on that graph moving to the left by whatever the value of c is. If you have a function that's f of x minus c, every single point on that graph is going to be moved to the right. So, as you can see, there's quite a few different types of changes that are all starting to look similar to each other. So it's really important you're taking good notes and keeping those straight. This one is a little counterintuitive because most people, when they see f of x plus c, they're thinking of shifting to the right, but it's actually the opposite of that. I'll try to explain that better in my next example. Okay, box 2 is an example. We're going to look at the graphs of f of x equals x to the third. We're going to do that one in red. And then a related graph, which is g of x equals x plus 3 cubed, and we'll do that one in green here. Okay. So our first function is one of your common functions, one you should know pretty well. It's going to be that graph that comes down, kind of has that squiggle in the middle of the graph, and then continues downward. I'm going to put arrows on the end there to show that it continues. And I'm going to label a couple points. So hopefully an obvious point here would be the point 0, 0. So we're going to put that on the graph. Another one is going to be the point 1, 1. So that's on the graph. And then I'm going to do another one down here, way down here, which is negative 2, negative 8. Okay? Alright, so we want to remember that when we have a change that's on the inside of the function, that's different, that's right here, that you're going to have a horizontal change, and that x plus 3 is going to move everything left 3 units. So I'm going to take that one point and move it to the left 3 units. I'm going to take that point, move it to the left, and I'm going to take this point and move it to the left. I get 3 new points. Only the x-coordinate is going to change, so this is negative 5 comma negative 8. Alright, this one up here is going to be negative 3, 0. And this one is going to be negative 2, 1. So again, if everything's just moving to the left, only the x-coordinates will change. Alright, here's what you're going to end up seeing when you do the entire graph and kind of think about what all the points are doing. You're going to have the same shape graph, but everything has been moved exactly 3 units to the left. Okay, box 3 is going to be a you try. We're going to try a multiple choice picture example. So down below here I have one of your common functions, f of x equals x squared. What I want you to think about is what a related graph would look like if it was x minus 6 squared. Think carefully and choose the graph that you think is most correct. Alright, so from our lesson, we should recognize this as a transformation or a shift 6 units to the right. So hopefully you came up with a graph that was a parabola, a lot like this one, but every single point was moved 6 units to the right. The origin's a good thing to think about. Our original graph goes through the 0, 0, so our transform, our shifted graph, should go through 6 0. So